Hi, my name is Peter Cooperman. I am the head of marketing and strategy at Black Buffalo 3D. And today I'm going to talk about the rise of 3D in the construction industry. To provide some background on myself, I joined this company in 2020. I was the fourth employee here. Prior to that, I have 20 plus years experience in strategic sales, marketing, and planning roles at different companies that provide an innovative technology across a diverse set of industries. I also have some background in copiers and printing and software solutions, all geared towards doing jobs that were at one time manual and automating them. So I was very interested in joining this company before many people knew what a 3D construction printer was, or even a 3D printer, that means. So I was very happy to jump on board, and I'm hoping that after this session, you too have a good understanding of 3D construction and its applications and the technology that exists today. I thought it would probably be good to start off by taking a look at the state of the construction industry, because there's actually a ton of statistics out there that affect us every day. So we really need to improve construction methods based on what we see on this slide alone. So construction is currently 14% of global GDP. Now, it also employs 8% of the workforce. There are tons of positions open. You can see 380,000 construction jobs were unfilled in last January. So just in case this is recorded, that's January 2022. And the forecast for the amount of waste that the construction industry produces is going to go up to 2.8 billion, almost 3 billion tons of waste annually by 2025. And a stat that's not up here is that approximately 30% of all construction project materials end up in a dumpster. So when you drive by different job sites, you probably see several dumpsters outside, depending on the size of the project. They're probably picked up every couple of days or maybe every day on larger ones. And really, none of these processes that lead to waste and methods of building have changed for nearly 20 years. Everyone kind of follows the same process they did back in the 80s and 2000s. So it's been going on for a very long time. I think a lot of the challenges that are out there have actually been intensified by the pandemic. It's hard to argue against it. And you can look at these charts on the right. The building cost of construction with an index has steadily risen since 2012, but you can see in 2020 to 2022, it gets even steeper. Part of that is reflected in the housing market. It's very easy to see the difference there. Commercial real estate took a hit when people stopped going into offices, but is beginning to pick up now as people return to their jobs. But we update these charts and these diagrams in our presentations almost every month. And you see a steady trend that everything continues to go up over the last few years and the last few months. So everything that was intensified includes substantial costs and labor shortages. So prices of materials have been going up, and there just aren't enough people to work for the amount of jobs that we have to, the amount of people that we have to employ to actually get projects completed. There's really unpredictable lead times. There's been traffic at the port as different countries and areas dealt with COVID infections on the rise. It became more difficult to even produce supplies, and anything that's imported, you can put around 3 to 6 months extra on timelines for getting it in. Environmental pollution has been an issue for a long time, as I addressed on the previous slide, but now companies are starting to take a closer look at how they can improve and work towards a net zero building, whether it be commercial or residential. We have to improve processes. And across the board, I know I've said it a few times, but there's just higher construction material and commodity costs. So not only at the finished good level, but at the actual input level for inputs needed to make cement, concrete, to make walls. Even in modular building, we're seeing a really heavy increase. And there's just a lot of job loss in construction. I don't mean that people had jobs and they lost them, but rather we're losing applicants. Workers tend to avoid construction jobs. There's a big perception that they're dangerous, they're difficult. Um, Younger generation doesn't necessarily want to work that hard. No one wants to pick up or swing a hammer, for lack of a better term. And contractors have been forced, when they get hired, to pay subcontractors a large amount of money because there's not a supply of highly skilled workers. I know firsthand, I've seen on projects I've done around my home, that it's getting more and more difficult to find people to do a good job for a reasonable price. And even when I pay a premium, sometimes the quality of the work isn't there. So we have to do something about it. We have to get people interested in working in the construction industry, interested in building and being part of infrastructure build out. And I think 3D printing can definitely help. When we look at the market view related to commercial and industrial buildings, you can see these charts here. Once again, COVID-19 accelerated the growth of the e-commerce industry by 4 to 6 years. So the acceleration really brought on a high warehouse demand. So as people decided to buy more things online and not leave their house, it became less important to have retail space and more important to set up warehouse and industrial buildings so that we could do order fulfillment. So there's a big demand there. That demand continues. We see warehouses from Amazon popping up different places. We see a real need to compete and have a steady supply of whatever products companies are selling nearby to get them into consumers' hands. So how does 3D printing play into all of this? And where exactly did 3D printing start? So 3D printing's actual name is additive manufacturing. It's the manufacturing of solid objects by putting layer on top of layer in accordance with specifications that are stored and displayed in electronic form as a digital model. So that's the definition that I pulled offline. But really, I like to think of it as you're now designing, instead of in a physical space or prototyping in a physical space, you're designing digitally, and then the 3D printer or additive manufacturing machine is able to actually take that digital file and make something physical out of it. So additive manufacturing is basically building that physical item up one layer at a time. And really, 3D printing was invented by someone named Charles Hull many years ago. It began as small scale prototyping or limited prototyping, as stereolithography, as additive manufacturing, different techniques, but it was highly, highly expensive and difficult to obtain a 3D printer. Now you could probably search online when you take a break from listening to this course, and you could find 3D printers, desktop models for as little as $99 that might take some tweaking, but can actually, print and teach you how to 3D print different objects in your home for a very low point of entry. So that happened probably over the process of around 15 years. What we did at Black Buffalo 3D is we leveraged the advancement in 3D printing technology and we scaled it up and made it much bigger. So our 3D construction printers, the Nexcon 1-1, which is shown in this slide, is able to print up to 4 stories tall and 1,600 square foot footprints. And it relies on a lot of the same technology and process as the desktop models on the previous slide. A big part of why we're able to make such big, reliable structures is actually the material. And we'll get into that a little bit later on. But you can see on this slide alone, we started prototyping with different wall segments. You can see it on the center of the image where the gentleman is standing. We actually tested a ton of different formulas for the cement-based ink that is now branded Planetop 3D in the Americas. You can read more about that, and I'll cover some more a little later. But we really designed these printers to take on the challenges that we spoke about earlier of traditional construction to create homes, buildings, and structures, and automate a lot of the process. So 3D construction printing, as it stands right now, has the efficiency to literally print homes overnight. So a 1,600 square foot footprint, whether it be a home or a commercial building, can print with a layer speed of 9.8 inches per second, which is capped by an OSHA safety regulation. We can actually go faster than that, but we're not allowed to yet. We'll try to change that regulation. And in approximately 30 hours time, we can have a 1,600 square foot floor plan with interior walls printed out. So that takes around 30 different super sacks of material. A super sack is a 3,000-pound bag of ready mix, and we deliver it to our customers along with the printer, where they just add water. There's a mini batch plant, for lack of a better explanation, that goes to mixing the ready mix formula, and it funnels it through the printer. And I'll show you guys a video of that a little later on. So there are a ton of opportunities for 3D construction printing. It's not only about homes or disaster recovery, it's also industrial and precast. And as demand for new structures and infrastructure projects play out, whether it be due to government incentives or just needs of rural communities or industrial communities, we are growing and we still need more. So we have to figure out how to do that. And from the Black Buffalo perspective, our clients are printing affordable housing. They're also talking to FEMA and different organizations about disaster recovery and, more importantly, disaster preparedness, because buildings printed with cement ink are actually a lot stronger than how we traditionally build, which is a lot of lumber on residential, and even stronger than modular buildings for the most part that are made on a lot of warehouses. Our material in essence can withstand winds of up to 300 miles an hour, even though it was printed on site. So there's a lot of demand for commercial, industrial, and precast. There's also potential to do modular buildings in a 3D construction format where different components of buildings or panels to reface buildings are actually printed off or near site and brought on to be attached to existing buildings, or brought on site to actually construct brand new buildings and facilities. So who exactly is Black Buffalo? How do we get into the business? I spoke about it a little bit earlier, why, but we're actually a subsidiary of Big Sun Holdings Group. We provide equipment, materials, and training, and we were founded originally by Dae-Sun Chung, who is a member of the Hyundai family. We're not directly tied to the car company, but he is the grandson of the founders of the Hyundai company. And for many years in South Korea has had businesses related to all types of construction, IT, and technology, including blockchain, IoT devices. And his companies have built everything from tiny homes with 3D printers to large-scale construction projects and apartment complexes. So we are part of them. And basically how we fit in is Big Sun Holdings. Everything on the right side of this slide is based in the US. We have a business called Flash Labs that does blockchain-based solutions. And then we have Black Buffalo 3D that does the 3D construction printers. We sell, lease, finance, and make them available. But we also do a ton of trainings just like this one to teach people about 3D construction, not just Black Buffalo. And under Black Buffalo, we have two subsidiaries. We have Black Buffalo Financial, which allows us to lease, finance, and rent our printers, not just offer them for straight purchase, so they can be used on a project basis. And then we also have a modular business. And the modular business came about because a lot of manufacturers of tiny homes had the supply chain issues I spoke about earlier, and they were looking for a way to beat them. And the way to beat them is to potentially 3D print the components or the actual units themselves. So we took that and we recognized that 3D construction might not be a fit for everything. So now we also have licensee agreements with several different modular tiny home builders that were not available in the United States that we're making available. And over the course of the next year, we will also work to 3D print some of those models to make them more affordable and easier to attain. Black Buffalo 3D is not a developer or builder. We are a technology company. So our aim is to provide complete 3D construction solutions and to really focus on making the best equipment, offer the best training, and the best materials available for 3D construction projects. This allows us to rely on the expertise and partner with our clients. Rather than saying we know everything about building, we've heard it firsthand before we even launched our first project or product rather. We had over 200 companies come and evaluate our prototypes. So I'll get into that a little later. We have a lot of key innovations. We have a modular gantry 3D construction printer, which is behind my back, which is part of my background right now. So that's just a big 3D construction printer that can be built to suit the project. We've also invested heavily in material science with a proprietary cement ink formula I'll talk about later. And all of our work has been done to increase efficiency and reduce waste on job sites. We also continue to invest in different combinations of both equipment and materials to lead the future growth of the industry. Black Buffalo is a leader in responsible 3D printing. When we are training our clients on how to use the printer, we're also making a point to show them how to reduce waste to as little as possible by either using molds when they're setting up the printer and getting the material to the right consistency. And at the end of the day, rather than flushing the system if they're done with their print job, they can actually have a few different stored applications and programs for printing benches, planters, or something useful rather than sending any excess material to a waste or recycling facility. So we work very hard at that, and we take it very seriously. We also train people how to be safe around the equipment. I think these are very safe machines to use. We just have to teach people to not kind of get in a daze of watching a building being printed. Oh my God, I hate this slide. We are a leader in responsible 3D construction printing. We teach all of our clients ways to improve and reduce waste. So rather than putting the material into a bucket or a garbage pail, we try to encourage them to use molds while they're setting up the material for the right consistency for printing walls and structural elements, and also to have a few files on board the controller so that if there's an excess amount of material and they're done with the print job, they can actually print out a bench or a garden box or something useful rather than sending it to a waste facility or recycling facility. So there are a ton of benefits to 3D construction printing, but that's not to say there aren't barriers. And there are several common barriers on why people may not have adopted 3D construction printers. So let's talk about those for a little bit. I think one of the #1 challenges that people have, or at least had over the past few years, and it's getting much better, is that the industry really needs standardization. This is new technology, but it's very similar to masonry. So people have to kind of understand what it is in order to accept it. So Black Buffalo 3D recognized that the industry really needs standardization. Our team started the first ever 3D Construction Printing Association back in 2020 when we were just getting started in the US. You can read about that at 3dctrade.org. And our goal was really to call every other company involved in the industry, whether it be on the material side, the machine side, the project side, and try to work with them to create a catalog of information about 3D construction printing. We also reached out to potential partners in complementary industries, precast companies, modular builders, even small scale 3D printers, not the construction type, and software companies that work with those printers also work with ours. So we reached out to them. But companies were very close guarded. I can't say we totally blame them because we were a new player on the block. And now that we're more established, we'll try again. But the challenge was if everyone wouldn't work together, someone had to step up and just kind of work towards standardization. So we found the only building code criteria for 3D construction. And when we looked at it, we realized it was already outdated. So we were going to do something about it. There's a bunch of other common barriers to 3D construction. There's startup costs because the printers are relatively expensive for a company starting out, not too expensive for an established construction company, but as I mentioned on earlier slides, it's hard to get them to change. There was inconsistent materials and testing. No one had really done anything that was verified on a standard level by any kind of international building code standards. Many manufacturers also competed on some level as a developer or contractor. So you weren't exactly sure if you were buying a printer, if they were going to then undercut you on materials or try to take the more attractive jobs. So it was really difficult for companies looking to get into 3D construction because it's hard to properly price projects and estimate time to recover initial investments if you're paying close to $1 million for a piece of equipment and you don't have guaranteed jobs yet. There's also a limited trained workforce, and luckily that's getting a lot better these days, but there's still a lack of inventory of printers. I know on our side, we had trouble keeping up with demand for our printers versus what we were able to manufacture. So here at Black Buffalo, we work towards making 3D construction more accessible. We have a global production and distributor network now, with distributors in Canada, Mexico, working on one in Brazil, Saudi Arabia, and Australia. We also have regional headquarters at Black Buffalo Asia in Seoul, just in South Korea. And also in New York, we have a office building, but in Pennsylvania, we have an assembly, training, and manufacturing facility. In New Jersey, we have an R&D team. So we're doing what we can to make these types of trainings and information about 3D construction accessible all throughout the world. We also created Black Buffalo 3D Financial, which is a flexible rental and purchase program. So a lot of these equipment manufacturers, and there are a few out there in the industry, only offer straight purchase or maybe leasing with no option to own. So they were all very expensive and cost prohibitive. So what we did was we took Black Buffalo 3D and created BB 3D Financial. And now we are able to do short-term rentals similar to really heavy equipment in the construction industry. So you can rent from 12 to 72 weeks. You can clearly define budgets for your projects, and you can basically map out how long you need a printer based on a simple calculation of uploading your traditional drawings into a digital program that will convert traditional architectural drawings to digital files, and then it will put it in something called a slicer that will tell you how long it takes to print out each specific building. We also have a lot of financing options. We have FMV and dollar buyout leases and really good rates. So if you do know any companies that are interested in getting into 3D construction, have them reach out to us and we will see if it's a good option for them. So the benefits of rental address some of the issues I spoke about earlier, because now you can rent for as little as 4 weeks, which is a typical project timeline for multiple unit projects. You have training included. It includes the complete setup of what you need for a printer, and it allows you to provide accurate quotes. It also allows our buyers to try the technology so that they can find out firsthand how well it works for their projects. And then they can actually apply part of the rental towards a purchase, which is what we're seeing happen a lot with many of our customers. So now that we have the financing out of the way, let's take a look at building code standardization. So building code standardization, the International Code Council develops building code and residential code. So it contains regulations about practices used in commercial construction and residential construction. And the ICCES is the leading evaluation service for building materials, components, and systems. So it also created the only criteria in the world for 3D printed walls, and that's recognized in over 50 countries. That's called the AC 509. So Black Buffalo 3D decided, after getting the equipment done and actually in parallel to designing 3D construction printers, that we would test to the AC 509. So the AC 509 is a criteria that addresses wall construction using 3D printing. It evaluates at the mix or powder level. It evaluates at printed core samples and printed walls as well for fire safety and material durability and structural strength. It outlines specific sampling and quality requirements that have to be fulfilled to obtain code compliance, and basically be able to build buildings in over 50 countries. So our goal in testing to the AC 509 is to make it much easier for our buyers, which are developers, builders, contractors, to get their projects approved for 3D construction, and also so it makes it easier for them to explain to local building jurisdictions, building and zoning, exactly what they're doing with our 3D construction printer and material, and the end result that they're going for in terms of strength and durability. So at a very high level, looking at the AC 509, they're looking at the flow of the material when it's going through our hose to be printed out. They're looking at the set time, how quickly does it cure and how strong does it cure. They're looking at the density and viscosity, and then they're measuring compressive strength and also linear shrinkage. So when you're done printing a 10 or 20 foot wall, it should be 10 or 20 feet or less than 0.6 of an inch less per every 10 feet. So that's one of the tests they do. It was one of the most difficult for us to pass, and it's something that we're very proud of that we accomplished. So the timeline for us testing for the AC 509 actually started at rewriting the code. The original criteria for AC 509 was only up to 8 feet tall walls, 8 foot tall walls, which is very difficult to scale if you can only go 8 feet when most of the buildings in the world are higher than that, or at least I know I'm relatively tall. I don't want ceilings that low if possible. So we started there. Then we had to define the test criteria once we were able to get the change approved through ICC and all of their members. Then we started in-world testing. We actually partnered with MAPE, which is a provider of grout and different materials. And then we started our lab testing process when we got to formulas that we liked. So we did that through Intertech, and we're totally complete. Currently, the scientific paper and write-up is happening, and we'll get the final approval for that in Q4, probably. By Q4, rather. So what's real-world testing look like? To this point, I haven't showed you guys too many pictures of what we do at Black Buffalo 3D, but part of that is because for the first couple of years, we were doing things like this. So we were just testing all different types of samples and walls with different time between layers to test how the material bonded. We were testing different shapes to see the flexibility of 3D printing, and if it was true, and it is, that you can truly print practically anything that you could draw on a napkin and make it a structural product. So this is a picture of some of those tests. This was one of 2 16-hour straight print days that we did as part of the testing. So let's take a look at the actual printing technology, the machines, and learn a little bit about the material. We couldn't have done any of this alone. I think in real estate as well, it's all about your network and who you work with and who you know. We quickly identified MAPE as a material partner. They're a worldwide company. They produce a number of building materials. And Also adhesives for the building industry. They have 53 plants worldwide. It was important to us that any material we developed would be available globally. And they ship tons of materials. So they have tons of customers out there that trust in the MAPE name. And we want to make sure we were working with a trustworthy partner. Then on the machine side, rather, we partnered with Tate. Tate is one of the leading providers of gantry stage and gantry structure solutions in the world. So I'll talk about our prototypes and getting from prototype to commercial. But basically, once we thought we had a very good design to make it commercially viable and available throughout the world on our printers, we sent it over to Tate and we let them tell us where else we should fix or what areas that were potential points of failure we could correct. So we started in South Korea with the Nexcon 1 printer. It was the first prototype. It was actually invented and created in 2018. It was a smaller model. It printed around 100 square foot area. So a 10 by 10 foot room could be printed. It was fully functional, but it was very limited because it could only do small prints. But it was great for being able to prove out the technology, test initial materials, and just gauge the interest of communities. And that's where it started, basically, in South Korea. From there, the team of engineers and mechanical experts over in South Korea developed the Nexcon 1-1. It was a 4-story gantry prototype. It is one of the largest still in the world printers today. So it is still one of the largest printers in the world. It is capable of printing up to 4 stories tall and up to 1,550 square foot footprints. So on every level, you can have 1,550 square feet up to 4 stories tall. We still have this printer. If any of you happen to be in the Pennsylvania area, we have it outside our facility. It is still fully functional. We still use it occasionally, but it's really cool to see in person, and we love showing it off to any guests. We took what we learned from the first 2 prototypes, and we started our production of the Nexcon 1G, or first generation. So it is a modular printer. The pump and nozzle can be controlled individually. So the pump and system off on the side can be turned on or off. There's a hose that runs up to the nozzle, and the nozzle actually has a mechanism in it that you can start and stop. So when you're printing buildings for doors and walls, the printer knows where they are based on the programming, and it will stop and leave a gap for them. Our printer also has infinite track technology, which means that the tracks or rails that it sits on can be extended infinitely for larger print jobs. It also has several extensions available. So our basic model that we sell most commonly is capable of printing 1,600 square feet on up to 3 stories. But we're also able to add additional rails and add an additional extension to make that even bigger. So this model takes approximately 8 hours to set up and 6 hours to break down. So a common request that we get, depending on the type of project, is that maybe people don't need the height of that printer, but they want to make it a little more portable. So right now, possibly by the time you're watching this recording, we will have launched our current prototype, which is the Nexcon UG, or Fold. So the Nexcon UG is capable of actually being stored on a single flatbed truck, and it also is able to unfold and set itself up. So the time to print goes from 8 hours of setup time down to under 2.5 hours. So you have increased mobility because there's an onboard drive and wheel system, automated setup because there's auto leveling and hydraulic actuators to actually set up the vertical posts and get the printer configured very easily. It's also compact design, where the Nexcon 1G takes approximately 3 containers to be stored This can be stored on a flatbed. And this printer will also have a similar footprint of printable area of 1,600 square feet, but it'll only go up to 1 story high. So it's really targeted for affordable homes, single story commercial buildings, military and government applications, or if people are doing prefab or precast like building components somewhere, they can use one of these printers. Possibly more important than the printers is the actual material being printed. We were actually just in Guyana with the government down there, and we were giving them demonstration of 3D construction printing technology for a large infrastructure build out that's happening across their country. And the main questions we were asked about after they saw everything print was, how strong is the material? How long does it last? So I'm happy to say that we've tested different materials. We actually went through over 60 different formulations once we thought we had a good formula down, and spent over 10,000 hours of our time that we invested with partnership with MAPE and with labs to make sure we got the formula right. So we looked at those 60 formulas. We sent the best performing ones based on our own tests to the lab for verification. And we found that, you know, our material is probably the best 3D construction printing material in the world. It cures around 3 times as strong as a block wall. It is a lot stronger than any lumber house, and it can be used for applications from residential to commercial. And it's proven to really be a giant differentiator in the industry. So what does Black Buffalo offer? We offer a complete 3D construction printing solution. So we developed our own 3D printers in South Korea and the US by collaborating with both businesses and looking at the markets in each industry. We started really small, and then we scaled up when we had it correct. We commercialized the printer from the US side. We gathered feedback from over 200 visitors in order to do that. And really both the public and private sector had different needs. And I think with our technology and our materials, we were able to meet all of them. For the material science side, we knew that there was a need for standardization. I'm sure many people on this call will be calling to ask more information as more 3D printed buildings and homes pop up across the United States. And we worked very closely with all the governing bodies, and we're not going to stop there. We're going to do what we can to actually increase adoption and education of 3D construction. And we're happy to be the first company in the world to actually test and meet the criteria for the AC 509 and 3D printed walls. You may be asking yourself, you know, where do these projects exist? Are people using 3D construction in the United States? And the answer is yes. 3D construction really did start with commercial applications in China and some in Europe, but the US market is quickly catching up. One of our customers, Alquist, has a project that they've titled Project Virginia. And basically what it was is that they recognized rural America lacked affordable housing. They teamed up with Habitat for Humanity to actually 3D print 2 homes in Virginia that got them international recognition, including printing the first owner-occupied home in the world. And when they did that, they started getting a lot of inquiries, one of which was actually the city of Pulaski, Virginia. They also worked with the governor's office, because Pulaski is going to be adding over 3,000 new jobs in the next 5 years, but the city does not have enough housing to actually meet that demand. So you can't attract workers to a facility if you have nowhere to actually let them live. So Alquist met with us. They decided to become a Black Buffalo 3D client based largely on the fact that we invested not only in our machine, but also in our material. And they're going to be printing 200 affordable homes in Virginia. So I know that Michigan is a little far from there, but if you happen to be on vacation, the printing of those homes will start by September in 2022. And I highly encourage you to visit their job site or contact us about a visit to our Pennsylvania facility. Timeline for that project is the groundbreaking and immediate printing of 2 homes. The land prep is already underway, as you can see in those pictures. There's also separate acreage that is right around the corner from the initial 2 homes that is going to start for 72 homes, and that will start this year as well. And the rest of the projects will begin throughout the state to help resolve shortages. So Pulaski will be first, and then they'll be moving to Roanoke and a few other cities in the Virginia area. There are tons of videos on 3D construction printing available online. A lot of them are linked to our YouTube channel. I do want to see if I can get it to load up so I can show you a copy of or a demonstration of what it looks like. So please bear with me for 1 minute. And let's see if this works. So this video I'm about to play is from our exhibition at the National Association of Home Builders International Building Show in Orlando, Florida in 2022. It was February of 2022. I will say that the structure we printed had 8.5-foot walls on the back and around 3.5-foot or 4-foot walls on the front, so that you can actually take a look at how 3D construction printed walls are laid down. What was really cool about this is that we printed it in around 8 hours over the course of 3 days. We could have done it in 1 day at one shop, but we wanted everyone to actually see us printing live at the event. And then even, less than an hour after we finished printing, it's set up so quickly that we were able to actually let the audience, so some of the 80,000 people in attendance at that event, up to actually walk around and see the building. So let me play this video. Hopefully it works on your end. So I hope you enjoyed that video. I think it gives a pretty good overview of where the technology is at right now. Some of the questions that we get very often is, how do you finish the building? And there's several different answers to that. So we do actually have an attachment coming out that will scrape the wall flat if people want more of a stucco or traditional look. Many people actually use the advantages of 3D construction printing and the fact that it's a 3D printer to make a decorative pattern on the wall for demonstration purposes. It's very easy to lay it out with the finger roll pattern. And then depending on where you are in the country, on the inside of the walls, many people prefer sheetrock. In different parts of the world, they might stucco or plaster to get a flat finish, or they might just simply paint it if it's an affordable housing project. There's tons of flexibility. I would say treat any 3D printed wall as a block type project. And that is your answer. You basically handle it the same exact way as a block building. So I hope overall that this presentation was helpful. You learned a lot more about Black Buffalo 3D and 3D construction printing. If you do want more information, we can provide information about printer availability. We're able to make around 5 a month at this time. We're scaling it to 10 a month and then 20 a month to meet demand shortly. We also have materials available throughout North America through MAPE. So any distribution center and your builders and developers will know who provides MAPE products can actually provide our Planetop 3D ink. And if you do want to speak with our team, you could either use the contact form to reach out to me to request more information about 3D construction and its potential, or if you know someone interested in purchasing, they could fill that out as well and just write that you're interested in purchasing a printer. But I am also happy to answer any questions. All the questions that send to questions@blackbuffalo.io make its way to my desk from my team. So please let us know if we can help in any way. And we hope very soon that we're announcing some projects with our clients in Michigan. Have a great day.